Assalamu alaikum. So today we're going to do some integration by part. But before we start doing integration by part, so let's talk about integration by part a little bit. Integration by part comes from the product rule of the derivative. So when you have two functions f, g, and we derive them, so we're going to have f prime g plus f g prime. So when we integrate, so what's happened, we end up having fg equal the integral of f prime g plus the integral of fg prime. So normally they give us one of these questions, either this or this. So but if you see it from another side, it's the same thing, there's no difference. So but the point is, which one I have to pick is my function and which one I have to pick is my derivative. So when they give me an integral, so when they give me something, for example, x sine x dx, for example, so which one is my function and which one is my derivative? So this is the choice that the student should take before he or she apply integration by part. And this is my way how I deal with that question. What I'm going to show you is my way. It's not on the book, it's just my way that I use for every integration by part. So I noticed that there is three types of function such that their derivative behave differently. So the first type of function is polynomial function. So this function, when you keep taking the derivative, it's become a constant at a certain number of the derivative. For example, if I have x squared, if I do the second derivative, it's become 2. X cubed, it's become 6, and so on. This means I have certain number of the derivative, it's become a constant. That means the function vanish. This is what I call them, the vanish function. So those are like what I call them, the vanish function. That means they vanish after a certain number of the derivative. So most of the time I take this function as my function. So that means in terms of integral, it's become my f, not the derivative. So they are choose to be f. So in most of the book, it's like I'm using they are my u. This is the type of function which is I choose always is my u. But it may change based on specific cases. We are going to talk about a case. The second type of function are like trig and an exponential function, like especially sine, cosine. So sine, cosine, and exponential. So those type of function, which is their derivative come back all the time. For example, the sine second derivative is minus sine. Cosine second derivative is minus cosine. So that means this derivative come back. Exponential, if I do the first derivative, is exponential. So those type of function, I call them rotating function. They are very easy to integrate, and they are very easy to take the derivative of. So those are always my derivative. That means they're always my g prime. So which means this will be my dv. And I have the third case. The third case is the type where the function change the form. It's not the same. It's become new function. So like ln, tangent inverse, sine inverse. So all the trig inverse. So those type change the form. So if I take the derivative of ln, it's become 1 over x. Tangent inverse, it's become 1 over 1 plus x squared. You see, the function is different than the original one. So those, I call them variant function. And most of the time I choose them to be my f, which is u. But there is some special case. The special case, if I have two functions that they can be f. So which one should be f, which one should be the derivative? So the polynomial is easy to integrate. So always, if you have those together, choose the polynomial to be your derivative, and this should be your f. Always try to eliminate this function. Eliminate ln, eliminate tangent inverse, sine inverse, cosine inverse, eliminate them. You don't need them. So take the derivative of those, get a new function, which become more easier to integrate. And if you have this together, sine exponential or sine cosine, so in that case you can choose anyone to be your function and the other one to be the derivative. Anyone can be your function, anyone can be the derivative. That means the choice is yours. You're free to choose. If you have, for example, e sine x, I can choose e to be my function, sine my derivative, or I can choose e to be my derivative and sine to be my function. You will end up having the same solution. So when you end up having those two together, it's okay, choose anyone you want. When you have those two together, so always your polynomial is your function, and polynomial is your derivative, and ln is your or tangent inverse or sine inverse, cosine inverse, and any trig inverse is your function. So that's the key, which is I use most of the time to integrate any integration by part integral. So let's do some application about this. Okay, let's start with the first question here. We have integral of x sine x over 2 dx. Keep in mind, when you integrate using integration by part, it doesn't mean that you don't need to use substitution. You have to understand the point of substitution. The main point of substitution. The point of substitution is to make your function very simple. So use a simple function and integrate a simple function. So for example here, if I have x over 2, I don't want to deal with x over 2 inside of sine or cosine or tangent. First thing, let me make my question very simple. Let me substitute x over 2 by u or by t, because I'm going to use u later on. Let me make it t. So which means that I will have x will be 2t. So that means dx will be 2 dt. So now my integral will become this, 2t times sine of t times 2 dt. So it's exactly what I will end up having. So I will pull out the 2 and the 2, so it become 4t sine of t dt. Now my question is become very, very simple, and this is the main point of substitution, is to make your expression very, very simple. If you have any function inside of sine, cosine, ln, or any other function, so try to make the inside to be your u. At least you transform the whole integral to become very, very simple expression. So here my u will be very simple, because this is the rotating function, which is like called by myself rotating function. So this means this is going to be my dv, and this will be my u. So here u will be my t because it's a polynomial, and dv will be sine of t dt. So du will be my dt, and v is very simple, it's minus cosine of t, and you see it's very, very, very easy to integrate. So now here I know it's going to be the integral. If I have u dv is u v minus the integral of v du. So here my u is t, dv is sine t dt. So what is my u? U is t. What is my v? Is minus cosine. So I'm going to put minus here, cosine of t, minus v, which is going to be minus, minus, and minus become positive. So it's going to be cosine of t, and du is dt. And this is very easy to integrate because the antiderivative of cosine is sine. So it's going to be minus t cosine of t, yes, plus sine of t plus c. And keep in mind, you see, don't forget that 4. I didn't use it here because I don't want to integrate this by itself. Then here I will have 4, so I'm going to put 4 times the whole thing here. So my final answer after I substitute my t, so should be 4 times minus x over 2 cosine of x over 2 plus sine x over 2 plus c. You can distribute the 4 here if you want, or leave it like this. It is the same thing, but it's better to distribute and make it more simple. So, but this will be my answer. Here is the same thing as this type. You see we have polynomial and we have rotating function. So this will be my dv and this will be my u. Inside of function is very simple, so I'm not going to use any substitution here because I already have inside of cosine is just t. so I don't have to substitute anything here. So I'm going to put my u will be my t square, and dv will be my cosine of t dt. So here du will be 2t dt, and v will be sine of t. So now I use this formula. So u dv will be uv minus v du. It's uv minus v du. As you see, each time I define the type of function, it's easier to integrate. So here I will have t square sine of t minus, and we have 2t sine of t dt. So I'm going to put out the 2 here, so it's going to be t square sine of t minus 2 the integral of t sine of t dt, and this becomes the same thing as this one. You see, is the same idea. You see this integral here is the same thing with it. You're going to do the same process. We're going to end up having this answer. So it's going to be t square sine of t minus 2, and it's going to be minus t cosine of t plus sine of t. And here we have plus c at the end. So this is how we integrate. You distribute here, and you can have the final answer. So t square sine t plus 2t cosine t minus 2 sine t plus c, and this will be your final answer for that question. As you see here, it's not that hard to integrate as long as we define the type of function that we are dealing with. Here what do you have? We have polynomial, and we have which is what you call the variant function. Like I told you, when we have those two together, so I will always choose my variant function is my function, and this will be my derivative. So that's mean here I will have u will be ln of x, and dv will be x cubed dx. So here when I take du, so the ln disappear, so it's become dx over x, or transform, it's become new function, and v will be x to the 4 over 4. So now if I want to integrate this, so it's going to be the integral from 1 to e x cubed ln of x dx. So it's become uv, which is going to be x 4 over 4 ln of x. Don't put x of 4 next to ln of x, but put it before, because at least you don't get confused and you think this is multiplication with x and x to the 4, minus v du. So it's going to be 1 over 4 the integral of x to the 4 dx over x, and as you see here we can simplify. So this will become x to the 4 over 4. So by the way, here I should put 1e, and this is 1e, at least don't forget this, and of x 1e minus 1 over 4, and here will be 1e x cubed dx. And now it's more easier to integrate. 1e minus 1 over 4 times x 4 over 4 1e. So you just need to plug in now. So here this is 16, we will do it later on. So when we plug in e, it's become 1 here, this is e to the 4 over 4. Plug in 1 here, it's become ln of 1, which is 0, so we don't need to put this, minus, then I will have 1 over 4, which is going to be 1 over 16. So it's going to be 1 over 16e to the 4, and minus, and if I plug in 1 here, it's going to be 1 over 16. So I distribute the minus here, so I got e to the 4 over 4 minus e to the 4 over 16 plus 1 over 16. So here it's become my common denominator, so it's going to be 3. 4 minus 1 is 3, so it's going to be 3e to the 4 over 16 plus 1 over 16, and this will be your final answer. So here again, so what do we have? We have tangent inverse, which is a variant function, like I told you. It's function, if I take a derivative, will become a new one. So this will be my u, and what's going to be my dv? So dv will be my dy, because we have only one here, so it's going to be dv will be my dy. So which means that du, I take the derivative of tangent, which is 1 over 1 plus y squared dy, and v will be just y. Now I will end up having, so the integral of tangent inverse of y dy will be equal to vu, which is y tangent inverse of y minus v du. So it's going to be y times 1 over y squared, which is going to be just y over 1 plus y squared, and here I'm going to use substitution. So I take the derivative of this one, it will give me the top one, except there's a 2 missing. So, but the 2, we can create the 2 here. You see? So the derivative of this is this one. So here, I put my t is 1 plus y squared. So dt will be 2y dy. So which is what we have here is dt, and here is t. So if I wanted to get this by itself, so half of the integral of 2y over 1 plus y squared dy will be half of dt over t, which is going to be just half of ln absolute value of t, but I know that t is positive always. It's going to be half ln of 1 plus y squared, so I don't need the parentheses, so I just need to substitute this here and I'm done. So my final answer will be y tangent inverse 1 minus half ln of 1 plus y squared, and don't forget the c, it's very important. Don't take point off for just c. Alright, so this is for that type of question. So here is the same thing. So what do we have? We have rotating function and we have polynomial. So here is going to be my u, and this is will be my dv. So u will be 4x and dv will be secant square 2x dx. Now, but like I told you, I want to make my expression very simple, so I'm going to choose 2x to be my t. So that's mean 2 dx will be my dt. So here it's 4x, so which means 2 times 2x. So here it's become, let me do it in this way. So we have 2x sine square 2x times 2 dx. Do you see how I expand it? So this will be my t, and this is dt. So it's the same thing if I have t, secant square, not sine square, sorry. So secant square, it's going to be secant square t dt. You see, it's become very simple. Use substitution. It's not because you're not using substitution you're not gonna use it. It's like because it's not because you're doing integration by part I'm not gonna use substitution. Use the point behind substitution is simplify the expression. Simplify always your expression. It's make you to save time and you go fast when it comes to integration by part. So here my u is straightforward, like I say here, u will be here my t, and dv will be secant square dt. So my du will be dt and my v will be just tangent of t. So here it's going to end up having uv, which is going to be t tangent t minus v du, which is going to be just tangent t dt. And we know that tangent is sine over cosine, so this is going to be the same thing as tangent t minus the integral of sine of t over cosine of t dt. And we know that the derivative of cosine is negative sine, so I can put this here. So I can use my for example my w will be my cosine of t, so dw will be minus sine of t dt. So this will end up having, it's become let me put it here, so it's going to be t tangent of t plus the integral of dw over w, which is going to be any absolute value, t tangent of t plus ln absolute value of w. First I substitute w first, because this is the last substitution I did, last in first out. So ln of cosine of t, don't forget this t here. Now I substitute my t back, which is 2x. So this will become 2x tangent 2x plus ln of cosine of 2x plus c, and this will be my answer. As you see, I substitute each time I see it's needed. Substitution is a way that make your expression very, very, very simple. So I hope you got the idea. Alright, for that one again, you see we have polynomial and we have exponential. So this will be my u and this will be my dv. Why? Because I need to eliminate the polynomial, and this is just a rotating function, is always going to come back and it's easy to integrate. Again here, what I'm going to do, I'm going to simplify my expression. So I'm going to put my t to be minus p. I don't want to deal with the minus, so that means dt will become minus dp. So here we end up having t to the 4 is just p to the 4, so that means here it's become t to the 4 e to the t times minus dt. I put the minus here, I put just dt here. So you see it's become very, very simple. So now I'm going to choose my u to be my t to the 4, and dv is e to the t dt. So let me clear here because I need more space. So let me take off this one and pull this one up here to be my answer. So this is the answer for this one. Alright, so alright, so here, so it's clear now. So dv du will be 4t cubed and v will be just e to the t. You see it's very simple. Now it's going to be equal to t to the 4 e to the t minus v du, which is going to be 4t cubed e to the t dt. Oh, dt here, sorry. Now I do the same thing here. This is, I'm going to put out the 4 here, so it's become t to the 4 e to the t minus 4 the integral of t cubed e to the t dt. As you see here, it's become the same concept, except we have 4. This has become 3, so I'm going to pull out the 3, so it's going to be the same idea here. You see, if I have 3, I will have 3 here minus 3 t squared et dt and so on. So let me show it to you, and you're going to see the pattern how it look like. For this one, I'm going to just integrate this one, and you're going to see the idea. Then I'm going to substitute at the end. So if I do t cubed e to the t dt, the only difference between this and this is we have 4 here, we have 3. That means here we're going to have 3, and you're going to have 3 here, and so on. So I will do the same thing. So it's going to be u is equal 3, dv will be et dt. That means du will be 3 t squared dt, and v will be e to the t. And as you see, we'll end up having the same behavior. So it's going to be e is going to be t cubed e to the t minus 3 the integral t squared e to the t dt. So I do the same thing with the 2, but let me put this one in here, and I time it by 4. So my answer at the end, so this is only for that one, so that means I will have e to the 4 t to the 4 et. So it's going to be t to the 4 et minus 4, then I multiply by this expression, which is t cubed et minus 3 t squared e to the t dt, and this will be my integral. As you see, please notice this pattern. If you notice this pattern, you don't have to keep integrating, because this is the same thing as this one is the same thing as that one. So when you get that one, you get 4 here, so you have 4 here and 4 here out. When it's become 3 here, so you have 3 here and 3 out. So if I have 2, so I will have 2 here and 2 out. So did you see the idea? So here, let me distribute the 4, so it's going to be t4 e to the 4 minus 4t cubed et minus plus, so it's going to be 12, the integral of t square et dt. So this will become t to the 4 e to the 4 minus 4t cubed e to the t plus 12, and this will become t square et minus 2t et. You see, we'll reduce always by 1, so this cube become 2, so square become 1, so it's going to be et dt. Then I distribute, so I got t to the 4 e to the 4 minus 4t cubed e to the t plus 12t square e to the t minus 24, the integral e to the t e to the t. So here is 24 t e to the t dt. So now I need to integrate this. So if I have 1 here, so it's going to be the same thing as this type of function. Let me take off this bar. So here, let me take it from here. So it's going to be t to the 4 e to the 4 minus 4t cubed e, oh this is et, not e to the 4, what I'm doing here. So this is t, this is t, this is t, sorry for that. So this is t, this is t, here we have plus 12 t square e to the t minus 24, then I will integrate this, so it's going to be t e to the t minus e to the t dt, which becomes just e to the t. So this, I will put the answer right away, and this will be the 24, so it's going to be, the final answer will be t to the 4 e to the t minus 4t cubed e to the t plus 12t square e to the t minus 24t e to the t plus 24 e to the t plus my constant, and this will be my answer for that question. As you see, when you see a pattern, you don't have to keep integrating, just like you don't have to keep like choosing u dv. Just apply the pattern for the rest of the integral. Next question here again is the same idea. So I need to substitute first. I don't need to deal with e to the 4, so I'm going to put my w will be my 4t, so dw will be 4 dt, so which means that dt is dw over 4. So now I substitute here again. W over 4 is my t, so when I make a square, it becomes w squared over 16, so it's going to be w squared over 16 e to the w, and here it's going to be dw over 4. So this is going to be 64, I can pull it out, so it's going to be 1 over 64, the integral of w squared e to the w dw. As you see here, it's become very simple. So my u will be w squared, and my dv will be e to the w dw. So du will be 2. You see, it's the same thing as if you see the previous question, it's the same idea. So it's going to be w squared e to the w minus 2 integral of w e to the w, and so on. So this will be 2w dw, and v will be e to the w, so it's going to be uv, so it's going to be w squared e to the w minus v du, is going to be 2 the integral of w e to the w dw, and this is the same behavior, so this is the same thing as this one, which is I just integrate. So I will have w squared e to the w minus 2, but the power is 1, so it's going to be just w e to the w minus, if power 1 it's become power 0, it's going to be 1, just e to the w dw. So notice those patterns, it's going to make your life more easier. Then to integrate this is very simple, so it's going to be w squared e to the w minus 2w e to the w plus 2 e to the w plus c. Then you substitute back w, which is 4t, so it's going to be, and don't forget the 1 over 64, so this is 1 over 64, so the final answer will be 1 over 64 times, and w is 4t, so it's going to be 16t squared e to the 4t minus 2 times, which is going to be 8t e to the 4t plus 2 e to the 4t plus c. And if I distribute this, I will end up having 16 over 64 is 1 over 4t squared e to the 4t minus t over 8 e to the 4t plus 1 over 32 e to the 4t plus c, and this will be my final answer. Again, the same thing here. So I have polynomial, and I have cosine, which is what you call it, like rotating function. So here I have 2x, I don't need to deal with the 2x, I'm going to do substitution again. So I'm going to put my t is 2x, so this means t over 2 is my x, therefore I will have dx will be dt over 2. So x cubed will be t cubed over 8. So I'm not gonna use the boundaries, I'm gonna integrate this myself, then at the end I will use the boundaries. So this x cubed cosine 2x dx will be the same thing. If I substitute, it's going to be the integral of t cubed over 8 cosine of t, and here dt over 2. So 2 times 8 is 16, so it's going to be 1 over 16 t cubed cosine of t dt. As you see, it's become very simple to integrate. So my u will be t cubed, and my dv will be cosine of t dt. So here my du will be 3t squared dt, and v will be sine of t. So as you see here, when I simplify my expression, it's become very clear and it's easy to integrate. And when you recognize which one is your derivative and which one is your function, it becomes more and more simple, and you can even go faster integrating using integration by power. So here is going to be v u, which is going to be t cubed sine of t minus, which is going to be here 3t squared sine of t dt. So again here I will have my u will be t squared, and dv will be sine of t dt, which is going to give me minus cosine. So du will be 2t dt, and v will be minus cosine of t. So it will be just minus cosine of t. So here I will have t cubed sine of t minus 3 open parentheses, because I'm integrating only the inside, so it's going to be minus t squared cosine of t, minus become positive, so 2 I will pull it out, t cosine of t dt. So I will have minus here, and we have minus inside, so when I pull out the minus, it's become positive, so I prefer to do it ahead. So let me clean this spot. So let me pull this one here. This will be my answer, because I will need that space. Alright, so again here I distribute the 3, so it's going to be t cubed sine of t plus 3t squared cosine of t minus 6 the integral of t cosine of t dt. Again, here I'm going to use u to be my t, and dv, this is my cosine, so u is my t and dv will be cosine of t dt. So here my du will be dt and v will be sine of t. So again, here will become t cubed sine of t plus 3t squared cosine of t minus 6, and you multiply, this is going to be t sine of t minus the integral of sine of t dt, and this will be just cosine. So but first let me distribute the let me integrate this straightforward because it's just negative cosine, and negative become just cosine. So it's going to be t cubed sine of t plus 3t squared cosine of t minus 6 t sine of t, and antiderivative of sine is negative cosine, negative become positive, so cosine of t plus c, then I distribute the minus, and I substitute back my expression. So t is 2x, so it's going to be 8x sine of 2x, not 2t, plus here we have 3 times 4, so it's going to be 12x cosine of 2x minus 6 times 2, so it's going to be 12. It's going to be 12x sine 2x plus minus 6, so it's going to be minus 6, don't forget to distribute, minus 6 cosine of 2x plus c, and this will be your final answer for that question. I hope it's clear, and it's look like simple if you see it. Here again you see I have x squared, so I don't want to deal with x squared. First let me substitute. So I'm going to integrate this expression, 2x sine inverse of x squared dx. I don't want to deal with the boundary. When I substitute back, I will substitute the boundary back. So let me check back. Oh, here you see I forgot to put the boundary here, so this will be 8x sine of 2x plus 12x cosine of 2x minus 12x sine of 2x minus 6 cosine of 2x. I don't need the c here, but I need the boundary, so it's going to be 0 to pi over 2, not 2 pi. Let's see, when you have the boundary, don't forget to put the boundary. Alright, so when I plug in pi over 2 here, so it's become pi, so it's going to be 0. Here I will end up having 12 pi, which is going to be 6 pi, and here it's going to be just cosine of pi. Cosine of pi is minus 1, so it's going to be 6 pi, so it's going to be minus 6 pi. This will be 0, because when I plug in pi over 2 pi over 2 here, it's become pi. Sine of pi is 0. Here it's become 0, and here it's become minus 1, so it's going to be minus 6 pi minus plus 6, because here we have minus 1 times minus 6 is positive, or positive 6. Here we have minus 1, because when I plug in pi over 2 it's become pi. Cosine of pi is minus 1. Here we have pi over 2, which is times 12 is 6 pi, so 6 pi times minus 1 is going to be minus 6 pi. So now I plug in the 0 here, so this is minus 0 will disappear, 0, 0, and here we end up having minus 6. It will become plus, so it's going to be minus 6 pi plus 12, and this will be your answer when you substitute back. So I hope it's clear here. So the same thing here. So I'm not going to deal with the boundary. I will first substitute. I don't want to deal with x squared, so I'm going to put my t will be x squared, so dt will be 2x dx. As you see here, this will disappear, so that's mean I will end up having just sine inverse of t dt. So now it's straightforward. This will be my function and dt will be my derivative, so u will be my sine inverse and dv will be my dt. So my du will be dt over square root of 1 minus t square, and v will be my t. And I hope that you should, by the way, you should know the derivative of the trig inverse, because more you know the derivative, more it's easier for you to move fast. So now, so it's going to be uv, so it's going to be t sine inverse of t minus the integral of t dt over square root of 1 minus t square, which is the same thing if I have t sine inverse of t minus the integral of t times 1 minus t squared to the minus half dt. And here I'm going to use substitution, so my w will be 1 plus t squared. Keep in mind we have double substitution, we need to substitute back before we give the answer, so before we use the boundaries. So here 2 dw will be 2t dt. So here, so if I divide by 2, I got my t dt. So here it's become t sine inverse of t minus, and here I will have half out, and it's gonna be oh, here is minus, sorry for that. See, we can make silly mistake for nothing. Minus, that's mean I will have minus here, so the minus will pull out, so it's become positive here. So here it's become t w to the minus half dw, and we just need to add 1 divided by 1 minus half, which is going to be just 2, so it's going to be t sine inverse of t plus, and here is going to be half times here is going to be the w to the half over half plus the c, but I don't need the c here because I'm going to use the boundary after I substitute back. So this will cancel out. So now this will be equal to t sine inverse of t sine inverse of t plus w to the half, which is 1 minus t square, 1 minus t square to the half, which is square root of 1 minus t square. Now I got my integral, so what I do here, substitute back my t, so it's going to be x square sine inverse of x square plus square root of 1 minus x square square, which is x to the 4, and this between 0 and 1 over square root of 2. So when you plug in 0 here, it's become 0, this is become 1. So when you plug in 1 over 2 to the square, so it's going to be 1 half, and sine inverse of 1 half, sine of which angle give me half is 30 degree, I think, which is pi over 6. Yes. Alright, so here I will have, does mean we have pi over 6 will be sine inverse of half. That's mean you should know those stuff. So here I will have 1 over square root of 2 square, which is going to be 1 over 2 times pi over 6 plus, when I plug in here, is going to be 1 over 4, so it's going to be a square root of 3 over 4 minus, then I plug in the 0 here, so this is 0 cancel out, it's going to be just 1 here. So here is going to be pi over 12 plus square root of 3 over 4 minus 1. So it's going to be pi over 12 plus square root of 3 over 4 minus 1, and this will be your answer for that integral. So I hope you got the idea. So I do some mental math here, mental math, but I believe that most of you will use calculator, but please on the test maybe they will not allow you to use calculator, so try to know how to do this stuff without calculator. Alright, so last question. So here we have e to the minus y cosine y dy. Like again, I don't want to deal with any negative with exponential here, so first I'm going to make t will be my minus y, so dt will be minus dy, and we know that cosine of minus t is just cosine of t, so we know those stuff. So here when I substitute back, so it's going to be e to the t cosine of minus t times minus dt, so I'll put the minus here, so it's going to be dt here, so which means is minus e to the t cosine of t dt, and this is very simple to integrate. So now this is going to be, you see, like I told you, when we have both of them the same, because those are rotating function, I can choose any one I want. So I can choose this is to be my u, this is dv, or I can choose this is my dv and this is my u. Will not change a bit, but you have to see how this type of function work, so, or of integration. So let me choose my u to be my e to the t, and dv will be my cosine of t dt. But when you choose the first choice, you keep with that first choice. That means e to the t will be always your u, because it's gonna keep coming back, and cosine, that means sine will be your dv, and so on. So my du will be e to the t dt, and v will be sine of t dt. That means next time I will choose this is gonna be my u, and this will be my dv dt, so that I don't have dt when I integrate here. Alright, so here I will end up having minus, so this will be equal to minus, and I will have e to the t sine of t minus the integral of v du, which is going to be just e to the t sine of t dt. I distribute the minus, and it'll be e to the t sine of t plus the integral of e to the t sine of t dt. And when we have two rotating functions together, always keep moving down the quotient down, because when they are rotating, so that means this quotient will appear again. That means the same quotient will appear on the other side. So always this happen. So here again, I will use my u to be my e to the t, and the v will be sine of t dt. You see, I stick with the same choice. If I choose first my u here is cosine and dv is e to the t dt, I will stick with that choice for the coming integration part I'm going to do. So here du will be e to the t dt, and v will be minus cosine of t. So here I will have minus e to the t sine of t plus, and I will have minus e to the t cosine of t, and minus become positive, so it's going to be plus e to the t cosine of t dt. As you see this appear again. It's the same thing as that one. Do I have to keep going? No, I don't have to keep going. What I do, I subtract this on both sides. Because this appeared again, I subtract this on both sides. So what we'll end up having twice, e to the t cosine of t dt will be minus e to the t sine of t minus e to the t cosine of t. Now, I'm not looking for twice the integral, I'm looking only for the integral itself. Divide by minus 2 both sides. then I will have my answer right away. So e to the t cosine of t will be equal to e to the t sine of t over 2 plus e to the t cosine of t over 2 plus c, and this will be your answer. So this is what happens when you end up having two rotating functions together, is the function appear again. So don't keep integrating and you having the same function and you keep rotating around yourself. So be careful with that stuff. When the function appear on the other side, add it or subtract it based on the sign of the integral that you have on that question. Alright, so I hope if everything is clear about the integration by part. So please, if you have any comment about the way I present or the way I explain, so please do so, which will help me a lot improve my way of teaching. Thank you very much for watching the video, and Assalamu alaikum.